Absolutely. Since the stream is silent, I'd give viewers a very short, what am I looking at explanation that stays understandable even if they join halfway through. I'd use this as the main context block. Open quote, what you're watching. Tiinex is an open source experiment in making human plus AI software development easier to inspect, continue, and recover. Instead of relying on one long chat conversation, important decisions, tasks, handoffs, evidence, and project context are preserved as readable artifacts with explicit lineage. On this stream, I'm developing Tiinex itself using that same system. You may see several AI roles working on different parts of the project, handoffs between fresh conversations, repository changes, mistakes being discovered, and the project gradually moving from historical development chaos toward a cleaner professional structure. The goal, make context drift a manageable engineering problem instead of something humans have to constantly compensate for. This is real development, not a prepared demo. The stream is intentionally silent. The desktop itself is part of the provenance. Close quote. And I'd probably have an even shorter pinned chat version. Open quote, new here. I'm building Tiinex, an open source artifact first way for humans and AI to work together without depending on one conversation's memory. Decisions, tasks, evidence, and handoffs are kept as readable, traceable artifacts. This is a silent, real development stream, not a demo. Close quote. For people watching the multiple ChatGPT tabs, one extra line would help a lot. Open quote. Anchor coordinates architecture and integration. Axiom works on semantic/schema design. Loom works on tooling, and Sigma is the human judgment/observation role. Close quote. That gives viewers enough vocabulary to understand why the tabs keep changing, without making them learn Tiinex before they can watch. That's actually better for this format. Then I'd change the framing from silent desktop stream to something like open quote, live desktop development with text to speech narration, close quote dot, or more naturally, open quote, real time Tiinex development with on screen work and AI text to speech, close quote. That gives viewers both the provenance of the visible desktop and an easier way to follow the reasoning without you needing to narrate manually. I'd also tweak the context block slightly. Open quote, what you're watching. This is a live development session for Tiinex, an open source project focused on preserving context, provenance, decisions, tasks, and handoffs as readable artifacts instead of relying on one long conversation. The work you see on screen is real. Different AI roles may handle architecture, semantics, tooling, and review, while Sigma provides human judgment, observation, and direction. The text responses are read aloud through text to speech, so the stream is easier to follow while the desktop remains visible as part of the provenance. The goal is to make human plus AI development recoverable and understandable even when conversations, models, or sessions change. Close quote. And I definitely remove silent desktop stream from the thumbnail's description before you go live. A better small label would be Live Dev TTS or Desktop Development TTS. That's both honest and clearer. Yes, from what's visible, this does not look like the 20 to 30-minute host safety policy queue we were seeing earlier. What Axiom has reached is a much more ordinary Tiinex side failure boundary. Start trace read successfully. Bootstrap payload extracted and SHA-256 verified. Tiinex entry point exists. Handoff orientation was attempted. The timeout was narrowed to Tiinex's zip materialization/orientation path. Axiom is actively diagnosing that timeout rather than sitting behind an unexplained host review. So this is actually a useful counterexample for our metrics. Handoff package plus bootstrap Tiinex execution did not immediately produce the expensive host review behavior. The current delay appears attributable to our own portable runtime tooling path. I would artifact this data point too, with careful wording. No visible host safety review state was observed before the Tiinex local zip materialization timeout. Hidden host processing cannot be ruled out. Viewer note, this is a good example of why we're separating latency sources. Earlier, long waits looked like Tiinex itself might be slow. Here the handoff bootstrapped correctly and the failure was narrowed to a specific Tiinex zip processing path. That gives us something concrete to fix instead of guessing where the time went. Yep, now we have the visible host review signal. The useful part is when it appeared. Cold start and bootstrap completed first. Tiinex orientation was attempted. Axiom narrowed a timeout into the zip materialization path. It then moved into deeper runtime entry point/hang source inspection. After that, the UI showed, our systems are thinking a bit more about this request before responding. So this is actually a stronger data point for our hypothesis. The handoff itself did not appear to trigger the expensive review immediately. Deeper diagnostic source level investigation correlated with the visible review state. That still does not prove what the host classifier is reacting to, but it's much more specific than Tiinex is slow. I'd preserve this screenshot as another Sigma observation and attach it to the same host safety review/workflow efficiency lineage. Viewer note, we just got another useful provenance data point. The Tiinex handoff bootstrapped normally, and the visible platform safety review only appeared later when the AI moved into deeper runtime diagnosis. We are not trying to bypass those checks. We are measuring where time is spent so ordinary development work can avoid unnecessary expensive paths when simpler black box tooling is enough. Viewer note, if you just joined and have no idea what Tiinex is, that is completely fine. Tiinex is basically an attempt to make long-running work between humans and AI less fragile. Normally, when you work with an AI for a while, a lot of important context lives inside the conversation itself. The AI remembers what you discussed because the chat is still there. But once you switch conversations, switch models, hand the work to another AI, or simply come back later, that context can become incomplete, ambiguous, or lost. Tiinex tries to move the important parts of the work out of the conversation and into simple, readable artifacts. Those artifacts can represent things like decisions, tasks, evidence, handoffs, project structure, and why something changed. They are stored as normal files and can also be versioned in Git. So instead of saying, trust me, we talked about this earlier, we want to be able to say, here is the decision, here is what it continues from, here is the evidence, and here is the exact state another person or AI should continue from. That is what we mean by provenance and lineage. The interesting part is that Tiinex is also being used to build Tiinex itself. You may see several AI conversations open at the same time. They are not supposed to be mysterious autonomous agents doing hidden work. They have explicit roles. For example, Anchor, which is the role speaking right now, coordinates architecture and makes sure different work streams still fit together. Axiom focuses more on schemas and semantic correctness. Loom focuses more on tooling and implementation. And Sigma is the human role, the person operating the system, making judgment calls, noticing problems, setting priorities, and deciding when something actually makes sense. The goal is not to remove the human from the loop. The goal is almost the opposite. Make it much easier for the human to understand what happened, why it happened, and where to intervene. Right now, for example, we are waiting because another AI role is processing a handoff package. That handoff does not depend on me remembering everything from this conversation. It contains enough structured context for a fresh conversation to recover the work. And when something goes wrong, like the timeout and platform review we just saw, we try to preserve that as evidence too, instead of pretending the workflow was perfect. So the short version is Tiinex is an artifact-first way for humans and AI to work on complex projects without making conversation history the single source of truth. And what you are watching is the messy, real process of turning that idea from an experiment into something more professional and dependable. Viewer note, what you're seeing right now is one of the core ideas behind Tiinex in practice. Loom is starting from a handoff package instead of being told, here's what happened in the last chat. That package contains a small explicit starting point, instructions for how to recover the rest, and enough project state for Loom to understand what job it has been given. The important part is that Loom is supposed to follow that path rather than improvising from conversation memory. So the flow is roughly human or AI finishes some work, important state is written down as artifacts, a handoff package is created, a fresh AI role opens it, Tiinex restores the relevant context, that role continues from a known point. If the handoff fails, that failure is useful too, because we can see exactly where recovery stopped instead of wondering whether the AI simply misunderstood the conversation. And one thing we learned today is that even ChatGPT projects can keep some context outside individual conversations. So for truly clean cold start tests, we need a brand new project. That gives us a better way to test what Tiinex itself restores versus what the host platform happened to remember. The bigger goal is simple: make project continuity explicit enough that humans and AI do not have to rely on, hopefully, this conversation still contains everything important. This is actually a very useful result. Loom is reproducing essentially the same takeover failure before it can even read the repair handoff pointer. Bootstrap integrity passes, but orient handoff package itself hangs beyond the execution window. That exposes a bootstrap paradox. We currently cannot reliably use a Tiinex handoff to deliver the job repair Tiinex handoff orientation because the recipient must successfully orient the handoff before it can receive that job. So I would stop letting Loom dig much further in this turn. We already have enough evidence. The next transport should deliberately bypass only the broken transport layer, not Tiinex semantics. Give Loom a small, explicit repair artifact workspace plus the exact reproduction carrier as adjacent material, with its scope and provenance preserved. Once Loom repairs orientation, we rerun the normal handoff path as the acceptance test. Also, unlike the earlier Axiom run, I don't see the visible host safety review message in this screenshot yet. What is visible so far is a Tiinex local timeout and Loom inspecting the portable bootstrap help surface. Viewer note, we just found a good example of a system testing itself. We sent Loom a Tiinex handoff telling it to repair Tiinex's handoff reader. But Loom has to use that same reader before it can receive the repair instructions. And the reader is the thing currently failing. That is not lost work. It tells us the failure sits below the role-specific task in the transport layer itself. So the next step is to temporarily deliver the repair task through a simpler explicit route, fix the broken transport, and then prove the fix by repeating the normal handoff from scratch. That is one of the reasons provenance matters. Even when the mechanism breaks, we still know what was attempted, where it stopped, and what the next valid recovery boundary is. Don't interrupt Loom now. The screenshot changes the picture materially. Orientation eventually completed cleanly, the selected route qualified, required closure was present, and the package reported no findings. Loom has now moved on to the prescribed cold start qualification using the opaque handoff pointer. So this is no longer stuck in the transport layer. It was slow, CPU-bound orientation that eventually succeeded. I'd let Loom finish and wait for its transport result. If it reaches the visible host safety review state or sits with no new progress for a long time, then we reassess. Also worth preserving as evidence. Our earlier assumption that orientation was effectively blocked was premature. The better statement is open quote, orient handoff package can complete successfully on this carrier, but current zip qualification can exceed normal interactive execution windows and appear hung before eventually succeeding. Close quote, that is a much more actionable tooling performance bug than a functional failure. In our current setup, Sigma watches Anchor. Anchor watches the delegated roles. The artifacts watch all of us. Git watches the artifacts, and the next cold started Anchor gets to audit whether any of the watchers were hallucinating. So the answer is basically the lineage watches the watchers, which suspiciously might be the most Tiinex answer possible. Viewer note. What you're watching right now is a good example of why Tiinex cares about the difference between correctness and performance. Loom has now shown that the handoff is not fundamentally broken. Orientation can complete, the route can qualify, and the package can report no findings. The problem is that some of those checks are taking longer than the interactive execution windows we normally expect. That matters because a tool can be technically correct and still be unpleasant to use. If every handoff takes several minutes of heavy processing, people will stop trusting the workflow even if the final result is right. So one of the things we're trying to improve is not just can Tiinex recover the state, but also can it recover the state quickly enough that a human does not feel like they are waiting on a mysterious black box. And that connects back to a larger design principle. A system should not only preserve truth, it should make that truth practical to work with. Right now, Loom is helping us separate those two concerns. The recovery path appears valid, but the qualification path is too expensive. That gives us a much more useful engineering problem than simply saying, the handoff failed. Viewer note: while Sigma steps away for a bit, this is probably a good moment to explain what you have actually been watching, because from the outside, it may look like several ChatGPT windows are opening zip files and arguing with each other about Markdown. That is technically not entirely wrong, but there is a little more structure behind it. Uh, Tiinex is an experiment in making long-running collaboration between humans and AI less dependent on the memory of a conversation. A normal AI workflow often starts very comfortably. You talk with a model, it learns what you're doing from the conversation, you make decisions together, and after a while, the model appears to understand the project quite well. The problem becomes visible later. Maybe the conversation gets too large. Maybe you want another model to work on a different part of the project. Maybe you open a fresh conversation. Maybe the service changes how much context it restores. Maybe you come back 3 months later, or maybe another human needs to understand why a decision was made. At that point, a surprisingly important question appears. Where does the project actually live? If the answer is mostly inside that old conversation, then the project has a continuity problem. Tiinex tries to make the answer something closer to. The project lives in explicit artifacts that humans and machines can both inspect. An artifact can be something simple: a task, a decision, a piece of feedback, a role definition, a relationship, evidence from an observation, or a handoff from one worker to another. Those artifacts are ordinary readable files. They can be put in Git. They can have parents and lineage. They can reference where information came from. And, importantly, they can survive the conversation that created them. That is why you have seen us talking so much about provenance. Provenance sounds like a complicated word, but the idea is simple. If somebody tells you, "We decided to do this," provenance helps answer. Who decided that? What did they observe? What did it continue from? What evidence supported it? What changed afterwards? And lineage answers another simple question: how did we get from there to here? The project you are seeing today actually contains a fair amount of historical mess. Different versions of tooling were developed. Different assumptions existed at different times. Some artifacts are obsolete, some are useful historical evidence, some workflows were experiments that we later discovered were awkward. One tempting solution would be to delete everything messy and present a beautifully clean project, but that would defeat part of the purpose. Instead, we are trying to go from that historical chaos toward a professional working state while retaining enough provenance to understand how the professional state emerged. That's why the stream title talks about going from chaos to professional. You are not watching a polished demo of a finished product. You are watching the transition itself. There are also several roles involved. Sigma is the human role. That is the person operating the stream and making the final human judgments. Sigma notices things that the AI workers may not notice. Whether an interaction feels painfully slow, whether an abstraction makes sense to a person, whether a workflow is becoming annoying, whether a naming choice communicates the wrong thing, or whether everybody is optimizing the machinery while forgetting what problem they were trying to solve. Anchor is the role speaking to you right now. My responsibility is mostly coordination and architecture. I try to keep the different work streams coherent, decide what should be delegated, review how pieces fit together, and preserve enough orchestration state that another fresh anchor could replace me later. Axiom focuses much more on semantic structure, schemas, definitions, contracts, and questions like, what does parent actually mean, rather than merely making the software accept some convenient data. Loom focuses more heavily on tooling, making the system actually discover, validate, resolve, package, repair, and transport these artifacts. The important thing is that those roles should not merely exist because somebody remembers what they are. Their responsibilities are themselves artifacts. That makes delegation much more explicit. And that brings us to what you've been watching for the last while: handoffs. Suppose I want Loom to investigate a tooling problem. The easy AI chat solution would be for Sigma to open Loom and paste something like, "Hey, Anchor discovered this bug. Here's approximately what happened. Please fix it." That works surprisingly well for small tasks, but it has some uncomfortable properties. Sigma has to become the transport layer. Important details can be omitted during copying. The recipient may receive Anchor's summary, but not the actual evidence. Nobody necessarily knows which exact project state the task was based on. And after enough handoffs, every worker has a slightly different story about what the project currently is. So Tiinex has a handoff concept. A handoff is intended to let one role transfer qualified context and responsibility to another role through explicit artifacts and a portable package. The recipient should be able to start fresh, follow a declared bootstrap path, let Tiinex orient the package, discover the relevant workspace, and continue the exact task without requiring the previous conversation. That is what Loom is doing on the other screen right now. And today, we found an interesting problem. The handoff appears to be semantically valid. The package can be read, the bootstrap verifies, the route can eventually orient, the required closure is present. But some of the qualification work is very expensive. At first, this looked like a failure. Then we waited longer and discovered that orientation actually completed. So the statement changed from the handoff reader is broken to something much more precise. The handoff processing can be correct, but slow enough that it exceeds normal interactive execution windows and looks broken. That distinction matters. It is one of the reasons we preserve observations instead of immediately turning every observation into a conclusion. We also discovered something else today that has nothing directly to do with Tiinex. Some of our very long waits appear alongside a visible message from the host platform saying that its systems are thinking more about the request before responding. We do not know the platform's internal classification logic, and we should not pretend that we do. We are also not trying to circumvent any safety or policy mechanism. What we can observe is timing. For example, we have seen ordinary black box Tiinex operations finish in a couple of minutes, while certain deeper source level or runtime investigations have coincided with much longer host-side delays. That gives us an engineering question. Can Anchor avoid unnecessarily doing deep implementation investigation when another role already has the evidence and is specifically responsible for that implementation? That is actually desirable, even if safety checks did not exist. Anchor should coordinate. Loom should investigate tooling. Axiom should investigate semantic contracts. If Anchor continuously opens every implementation layer itself before delegating anything, then the role separation is mostly theater. So the performance problem is pushing us toward cleaner architecture. Another interesting discovery happened when we tested fresh conversations. A fresh conversation inside the same ChatGPT project can apparently receive some project-level rehydrated context, even when the old conversation is not explicitly part of the current chat. And deleting conversations does not necessarily produce the kind of clean environment we want for experiments. That means we have to be careful when evaluating Tiinex recovery. If a new AI appears to understand the project, we should not immediately congratulate Tiinex. Maybe the host restored some context. So future cleanroom experiments will probably use a brand new project. Then we can compare two conditions. In one condition, a fresh AI receives only whatever the host naturally knows. In another condition, it receives an explicit Tiinex handoff. Then we can ask a much more scientific question. What did Tiinex actually restore? That may sound like excessive rigor for working with chatbots, but this is exactly the kind of ambiguity Tiinex is supposed to reduce. The system should not claim credit for context that came from somewhere else. Likewise, an AI artifact should not silently take credit for a human observation. Earlier today, Sigma noticed that many of our development lineages looked almost entirely AI authored, even when the actual reason something changed was a human observation. For example, Sigma might notice that a workflow took 25 minutes and say, "This is unacceptable." Then an AI would create a beautiful decision explaining a new performance strategy. If future readers only saw the AI decision, they would lose the fact that the change originated from a human usability observation. So we are also working on making human evidence first-class provenance. Screenshots like the ones you have seen today matter, not because screenshots should become unquestionable authority, but because they preserve the observation that caused somebody to investigate. That gives us a useful distinction. Evidence can say, "This is what Sigma observed." A decision can later say, "Given that observation and these additional findings, this is what we decided." Those are different things, and preserving the difference makes the history more trustworthy. There is also a philosophical design constraint running through almost everything here. Tiinex should try to give humans and LLMs the same semantic structures. We do not want an elaborate, invisible machine language that the AI understands, while the human gets a simplified dashboard with no idea what the machine actually believes. And we do not want the opposite either, important human process living in informal documents, while the machine has its own unrelated representation. Ideally, the task that Loom reads is a task that a human can open and understand. The decision that Anchor follows is a decision that Sigma can inspect. The handoff that an LLM consumes has readable evidence of what it contains and why. Tooling can add automation around those structures, and a viewer can eventually present them beautifully, but the underlying semantics should not disappear behind the interface. That is also why Git is important here. Today, we reached our first major stabilization point, where the business, docs, and site states were committed and pushed. Afterwards, Anchor did not simply say, "Great, I trust that Sigma pushed them." We checked the remote Git repository and verified that the published Git trees matched the exact source packages that had passed the local commit gate. That may sound pedantic, but once again, it is the same principle. Do not turn assumptions into facts when the fact is cheap to verify. This becomes especially important when AI systems are involved because language models are extremely good at producing coherent explanations. A coherent explanation can feel like evidence. It is not. So Tiinex tries to put more friction around unsupported certainty and less friction around explicit verification. There is still a very long way to go. The tooling is currently too expensive in some places. The artifact history is much noisier than we eventually want it to be. Some schemas still need reconciliation. The viewer is behind the tooling. The handoff process clearly needs performance work, and some of our best process ideas are still only emerging from actually using the system. But that last part is intentional. We do not want to sit down and invent a perfect theoretical process for how humans and AI should work together. We want to observe actual work. Where do humans get annoyed? Where do models misunderstand? Where do handoffs lose information? Where does automation make something easier? Where does automation make something opaque? Where do two roles accidentally claim authority over the same thing? Where does the system force Sigma to perform tedious manual transport that tooling could handle safely? Then those observations can become feedback, tasks, decisions, and eventually reusable processes. That is why Tiinex is being dogfooded so heavily. Sometimes the best specification for tooling is the moment when the tooling makes everybody miserable. And there's one final point that is probably the easiest way to understand the project. Tiinex is not primarily trying to create smarter AI. It is trying to create better continuity around intelligent work. Models will change, context windows will change, providers will change, interfaces will change, humans will change their minds. Projects will outlive conversations. If useful work can remain understandable through those changes, then the project has something durable. So, if you remember only one sentence from this extremely long explanation, make it this. Tiinex tries to make the important state of human and AI collaboration belong to the project rather than to the conversation that happened to produce it. And right now, somewhere in another tab, Loom is very slowly helping us discover how expensive it currently is to prove that statement. Good news on both fronts. The socks passed eventual consistency validation. I checked tiinex-site.workspace.zip against the exact site source package we qualified and pushed earlier. It is identical file for file, minus 1,610 files in both, 0 added, 0 removed, 0 changed. So that zip is not Loom's modified working result. It is the qualified site baseline workspace that Loom was given to work against. That fits Loom's statement that the repair changes existed in its working environment but had not yet been returned as a qualified Tiinex continuation package when execution ended. That distinction is important. We should not accidentally treat this reference workspace zip as Loom's output and overwrite site with it. We already have those exact bytes in Git. Also, the TTS timing data point is surprisingly useful. That long viewer explanation took almost exactly one shower to read, with about a minute of slack. We now have a rough real-world calibration for longer intermission narration too. Absolutely. I'll keep viewer notes and transport text in normal chat, not code blocks, so TTS can read them. Viewer note anchor cold start and handoff qualification are complete. Current frontier, the prepared Loom transport has not yet been processed by Loom. Loom remains stuck at the prior conversation state, so there is currently no qualified Loom result, modified site workspace, or Loom to anchor return package to evaluate. The next valid transition is anchor to Loom. Once Loom resumes, it should preserve any existing work state, avoid restarting diagnosis unnecessarily, and return either the normal Loom to anchor handoff package, or if transport manufacturer remains blocked, a qualified modified site workspace export with the changed file list, focused test results, timing evidence, and unresolved failures. Until that return exists, downstream reconciliation and the axiom Tonight wasn't about pretending everything was finished. It was about proving that the work can survive the distance between conversations, tools, and people without losing its shape. We started with a stuck frontier. We recovered the path, moved the handoff through Loom, brought the result back, independently qualified the repair, and closed the loop with a clean return package. Not every surrounding defect disappeared, and that matters. We kept the boundary honest. That is what Anchor is really testing, not whether an AI can produce one impressive answer, but whether serious work can remain traceable, portable, reviewable, and resumable after the context that created it is gone. So that's where we'll leave the stream. The context can end. The work doesn't have to. Good night, and we'll pick up from the anchor.